go through this. And again, it's very important, right, that you go over this on your own, right, before I do this. Okay, so I just gave this group in class, I just gave them another booklet, which I will post later on if you want to do it. So here we go, question 8. A ring is tossed into one of six boxes. With each toss, there's an equal chance of the ring landing in one of the boxes. A ring is tossed 100 times with the following results. White 22, not white 78 times. And just do a check, right? This adds up to 100. State the theoretical probability of tossing the ring into the white box. Theoretical, remember what should happen? You don't go by the actual outcomes. You go back to the original. There's one white box out of 6. So theoretical probability would be 1 out of 6, right? Which is 0.17 or 16.67%. I'm just going to circle the one that would be good enough there. Okay, that's it. State the experimental probability. Experimental is what actually happened, right? Of the ring not landing in the white box. Not landing in the white box. So experimental probability of not white, if you want to call it that, would be, there are 78, right? It happened 78, it actually happened 78 times that it landed on a non-white out of a total of 100, right? 78 out of 100. So this is, you're now considering what actually did happen, right? And that's 0.78 or 78% if you want to have options, but that would be good enough. 1 mark each. All right, next page. You're very likely to get something like that to test your knowledge of the difference between the two. Okay. The probability of being born with one extra finger or toe is approximately 1 out of 500. Calculate the probability as a percent. That should be an easy one, right? 1 out of 500 is equal to, if you divide it, sorry, this is the basic. You go 1 divided by 500 times 100. Whenever you see times 100, your answer will be as a percent. Okay, guaranteed. 1 divided by 500 times 100. And this is where a lot of students lost marks because they thought, hey, I'm getting 0.2, I'm going to multiply it by 100 one more time. And then they got 20%. Okay, and that was wrong. Okay, so it is just a very low chance of that happening. Let's continue this one here. What would be the odds for extra finger or toe? Add this. Okay, let's make this a B. What would be the odds for an extra finger or toe in favor? Okay, that'd be 1 out of 499. Right, because you go 1 and then 500 minus 1 over here. That would be the odds against. And then extra finger, extra toe, right? That'd be just 499 to 1. Okay. D, probability of not, I'm summarizing this, doesn't sound right, of not extra toe, finger or toe. What's the probability of not having an extra finger or toe? Probability of not would be right there, 499 cases out of 500. Okay, we're going back to total because probability is event out of total always. Okay. So I'll give you a little, you can add this to your study sheet. If you want to go from probability to odds, right, if you want to go from there, from probability to odds, you get probability of A happening, it'd be A over total, right? If they wanted the odds, you would go A total minus A. Right? That's how you would get it. So probability of white, for example, if it's 1 over 6, the odds of white would be 1 to 6 minus 1, which would be 1 to 5. Okay, that's an example. If you want to go from odds to probability, this would be A not A. Sorry, should be equal sign. Plus A to not A, right? In favor, against. You would then, to get the probability of A happening, would be A over A plus not A. So you would add these two numbers. And then of course, if they want a probability of it not happening, then you go A naught, but it's still A plus A naught. So it depends on how they word it, right? So Jets winning the next game. Let's say it's 7 to 9. Oh, that looks bad. Let's switch it. 9 to 7. We want Jets to have a higher chance of winning, right, than not winning. So this would be win. This would be loss or not win. So probability of win, you grab the 9, and then you add 9 plus 7, which is 9 over 16. Okay, I'm running out of runway here. Probability of loss would be 7 over 16. Okay, but together, win and loss always add up to, right? 9 and 7 add up to 16. So it's 100% combined. So write that down on your study sheet, perhaps. I'm going to leave it there for a bit, just for you to copy it. So copy it onto your study sheet. Now, I will pause this expected value. Okay, Stephanie offers horse-drawn carriage tours. It costs $30 per day to feed and care for the horses. Each day she'll operate either a premium tour, standard tour, or no tour at all. 3 marks, by the way. The table below shows the fee for each tour and the probability it will occur each day. So premium tour, this is the fee that she would be charging. There's a 10% chance she will be taking that. There's a standard, $50 for the tour, 50% chance. No tour, obviously you don't make any money, 40% chance of that happening. Calculate Stephanie's daily expected value. That's the key there. Okay. So expected value, there's a formula for it. I will give it, I'll talk about it again. Probability of win 1, let's call it, times the gain, plus probability of win 2 times the gain, plus that continues on for as many ways of gaining that there are, minus probability of losing and cost. Okay, you have to have a minus at the end. You have to. It's on your formula sheet, but it doesn't hurt to have this on. It's different on your formula sheet, I'll tell you that. It looks different. So here we go. Expected value, probability of winning, or the first way of earning money, you got to think of it that way for her, would be a premium tour, and there's a 10% chance that happening. And what would she be gaining? Well, she'd be gaining $100, winning $100. That's the prize, right? Let's go back up here. I'll call this win 1, win second way of winning, and this is just losing, right? No tour would be losing. It says that it cost $30 for her to basically play the game, right? The cost for you to run your business is $30 of a cost to feed the horses. So you go 100 minus 30 plus. Probability of winning the second prize is 50%. Always turning it into a decimal, okay? Dividing it by 100. And the gain there will be 50 minus the $30. So you almost forget about this. This happened, but how else could you win, right? Because only one of them happens at a time, okay? Minus the probability of losing is 40% and the cost is $30. By the way, let's put dollar amounts here. Then we know where these numbers came from, right? Let's clean that up. 0.10 times 70 plus 0.50 times $20 minus, that's already cleaned up, but we'll copy it anyways. Okay, then let's do each one individually. 0.10 times 70 is $7 plus 0.5 times $20 is $4 minus 0.4 or 0.40 times 30, that's 12. Sorry, this is wrong. This is $10, right? 50% of 10. 50% of 20, sorry. 50 times this is $10. Please correct that. This is 12. Right, so you've got the first way of winning, second way of winning, and then your loss. So we can do this in our heads, right? 17 minus 12 is $5. And I'll make a note. Expected value is positive. Therefore, win expected. So overall, you're expected to make $5 of a profit. per day, which isn't that much, right? Not a good business plan, but would still say you're expected to win. Notice that, use a different color. Notice that all three probabilities, if you add this up, that's 100%. So there have been instances where the no tour, the losing part, is not there. They would have just given you two ways of winning. So 10 and 50%, right? Look up here, right? That's 60. So you would have had to come up with the 40 here for that, knowing that all three of these should add up to 1 or 100%. Okay, so there it is. Next page, probably an easy one. One marker. We're good? Okay. In many soccer leagues, the odds in favor, that word is important to us. When you're talking odds, you want to know, is it in favor? Odds in favor of scoring a penalty are 7-3. And notice they don't use they use words, so it's 7-3. Right? State the probability and fraction, so they're very specific. Probability and fraction of not scoring. They're kind enough to already put that in bold, a penalty kick. So I always do this in steps to show you. Odds in favor, that means that the first number is in favor of scoring, right? Score, scoring, not scoring. Right? That's what the numbers represent because of the odds in favor. That means that the first one is in favor of scoring. Okay? They want the probability of not scoring. So remember, this is A and this is your not A, basically. And so probability of not scoring, you don't have to do this part, but I always like to put it down. It would be 3, right? You take the 3, and then it's 7 plus 3 in the denominator, so it's 3/10. And they left you a whole page just in case. So they could ask you to do this as a decimal, and you just write down, right? This divided by that, that's 0.3. As a percent, you would this divided by that times 100. Make sense? Right. We have 2 more questions for probability, and then we'll most likely leave vehicle finance for tomorrow. And what I'm going to do then is go through all the home finance questions with you, but you do them already, okay? Jose cuts down 60 trees per month. Each time he cuts down a tree, there's a 1% probability that he will need to repair his chainsaw. Calculate how many times Jose should expect to repair his chainsaw in 1 year. Do you remember predictions? Right? If you go back to probability, remember when we had the elections, like we had the surveys of the different candidates, right? Like we had the different candidates and the percentage, and then this was based on a smaller survey, and now you were expected to say how many votes would you have if there were 2,000 students voting. You would take the probability, so prediction is probability of the event right, times the total, right? Total number of, you know, people voting or instances or whatever. Okay. So what is the total? Well, if it's 60 trees per month, right? What is it in a year? Because they want to know what is it in a year. So I'm going to go up a bit. So go times 12 months. That's 720 trees. Okay. So he cuts down 720 trees a year. And there's a 1%, every time he cuts it down, there's a 1% chance that he's going to have to repair his chainsaw. So the prediction would be 1%, which is 0.01, or 1 over 100 times 720 trees. Right? And here's a kicker. I remember this now. This is coming back. This is 7.2 trees, or times. Right? Like, because 1% of every time you're cutting down a tree, so you're expecting it to be repaired 7.2 times, which is approximately, they didn't care if you round it up or down. I'm going to round up because just to be safe, right? Approximately 8 times he will have to repair his chainsaw because he's cutting down 720 trees. So you need to get the prediction, multiply it. So you got 1 mark for this and another mark for coming up with that. If you left it at 7.2, you lost half a mark for not rounding. Okay. One last question. 1 mark. Oh yeah, this is I was hoping that this was going to show up. This type of question, not this one in particular. A bag contains the following tiles. So A, B, B, C, C, C. David removes 1 B tile from the bag and does not return it. That should actually sound an alarm. Sorry, Booklet isn't cooperating here. Does not return it. Very important. Okay, we call that dependent events. Right, if you go back and look at the videos, dependent events. He then randomly removes a second tile. State the odds in favor of the second tile being a C. So how many C's are there? There are 3. And how many tiles are not going to be a C? Well, you basically have to almost consider that this is taken, this is gone, that's no longer in the bag. So if there are 3 C's, then there are 2 tiles that are not C's. 3 to 2. Okay, and I'm going to take a step back. Probability of grabbing a C would be 3 out of 5. So the 3 goes there. And how did we get that? Well, we went 5 minus 3 to get that. Used to be 6. Now we're down to 5. Okay. Okay, we're going to call it a day here.